One of the world's centers of climate modeling is the Goddard Institute for Space Studies in New York. It was here in the 1970s that a young scientist, James Hansen, began asking questions about the effects that human activities were having on the atmosphere. A student of physicist James Van Allen, Hansen had done his doctoral studies on the atmosphere of Venus. Venus is a primary example of the effects of greenhouse gases.
Venus is closest to Earth in size, mass, and gravity, but it has a dense atmosphere of carbon dioxide, and there's almost no water. The surface of Venus is extremely hot, with an average temperature of over 800 degrees Fahrenheit.
In modeling climate on Earth, Hansen's team had an imperfect set of temperature data to work with. To compensate, they simulated the motion of large air masses, which often cause similar effects on weather stations hundreds of miles apart. In 1978, Hansen chose to input climate data from a known event in the past to see if the model would recreate or hindcast the results. The eruption of Mount Agung in Bali in the 1960s had been well studied. Large volcanic eruptions eject huge amounts of dust into the atmosphere that reflects sunlight and can cool temperatures over a whole planet for a year or more. The study concluded that the magnitude, sign, and time delay of the temperature changes are in excellent agreement with those of the changes observed after the eruption of Mount Agung. It was a confidence builder for the young scientist. In 1981, he was back with a new study, this time not a hindcast, but a bold forecast of greenhouse effects a century into the future. The paper was remarkably prescient. Hansen wrote, "It is shown that the anthropogenic carbon dioxide warming should emerge from the noise level of the natural climate variability by the end of the century, and there is a high probability of warming in the 1980s. The report predicted a larger sensitivity at high latitudes, which has now actually been observed. In addition, Hansen's model predicted the erosion of the West Antarctic ice sheet, which is now underway, and the opening of the fabled Northwest Passage through Arctic ice, which actually occurred in 2007. Hansen's message was clear. The time to act had come. Unprecedented change was imminent. But it was the 1980s, and the country was unwilling to hear the message. We were told that trees cause pollution, that real men drove for oil, and government expenditures on non-fossil fuel energy, which had soared after the 70s oil crisis, dropped dramatically. The nation slept for 7 more years, and Hansen continued to refine his methods. In 1988, he was ready to sound an even more urgent warning.
Altogether, this evidence represents a very strong case, in my opinion, that the greenhouse effect has been detected and it is changing our climate now.
In dramatic testimony before Congress, Hansen presented 3 scenarios. Scenario A, a very high emission scenario, showed dramatic warming through the coming 21st century. Scenario B, considered the most plausible, showed a slower rise in emissions and temperatures. Scenario C assumed a rapid drop in carbon emissions and showed a slower rise and an earlier plateau in temperatures in coming years. Over the last 2 decades, actual temperature measurements have tracked closely with Hansen's Scenario B. But what is most interesting about the prediction is that Hansen built in a mechanism to check the assumptions in the model. Scenario B included a hypothetical large volcanic eruption in the mid-90s and modeled the global atmospheric response. Hansen gambled that such an event would prove or disprove the accuracy of his science. He didn't have long to wait for an answer. In June of 1991, Mount Pinatubo in the Philippines blew up in the most powerful eruption since 1912, ejecting huge amounts of reflective material into the atmosphere, similar to the Mount Agung event in the 60s, only larger. Over the following year, global temperature measurements showed a dip, a notch in the record almost identical to the one predicted in Hansen's model. It was a resounding affirmation of the predictive skill of Hansen's methods. Since 1988, the Intergovernmental Panel on Climate Change has periodically published continuing work and refinements on climate models. With each new iteration, climate modelers are able to slice their data ever more finely. The collected predictions of the last 20 years can now be evaluated. The first assessment in 1990, the second assessment in 1995, and the third in 2001 can now be compared to 20 years of actual data, and the results are impressive. In the most recent fourth assessment report, AR4, researchers collected results from 58 forecasting and hindcasting model runs from 14 different climate modeling groups. We can see the results are consistent and tightly grouped, and there is a close correlation between the average of all the model runs and the actual observed global temperatures. Also, over the last century, the models were successful in simulating the results of the largest volcanic eruptions. Climate science is not completely dependent on climate models. There are many threads of supporting evidence.
I would like to draw three main conclusions. Number one, the Earth is warmer in 1988 than at any time in the history of instrumental measurements. Number two, the global warming is now large enough that we can ascribe, with a high degree of confidence, a cause and effect relationship to the greenhouse effect. And number three, our computer climate simulations indicate that the greenhouse effect is already large enough to begin to affect the probability of extreme events such as summer heat waves.
You know, you have to say this is as much political theatre as scientific evidence. It was Hansen himself that suggested he give his evidence at the end of June, figuring that the weather would be hot. He wasn't disappointed. They were in the middle of a heat wave, so people were in the mood to write about global warming. He'd also checked that the press were going to be there that day, and that he was the first person giving testimony. This man wanted to make news, and he saved the best to last.
Altogether, this evidence represents a very strong case, in my opinion, that the greenhouse effect has been detected and it is changing our climate now.
It was pretty explosive stuff. Essentially what Hansen was saying is that global warming was no longer a prediction, it was now an observation. For the first time, a leading scientist had stepped off the fence and told the world global warming had arrived.
All of us must begin to face up to the fact that if we continue emitting vast quantities of the greenhouse gases, we're going to face a global temperature rise larger than anything experienced in human history.
Hansen succeeded. Thanks to him, global warming became an overnight sensation.
The time for action to respond to the impending warming is now.
Hansen later admitted that he'd weighed up the risk of being wrong against the costs of saying nothing, and decided that he had to speak out.
This evidence represents a very strong case.
Most scientists would rather not make a definitive statement, but the public doesn't always understand that. I mean, if you say on the one hand this and on the other hand that, it makes the public think, well, we don't know enough to draw a conclusion. And that can be unhelpful in terms of when you do need to have policy changes.
Basically, Hansen stuck his neck out. Not something that we scientists are famous for. I don't think I'd have been enough to do it. But perhaps fortune favours the brave, because Hansen's testimony has stood the test of time pretty well. Within a few months of Hansen's evidence, the United Nations had helped set up an international committee to examine global warming, the Intergovernmental Panel on Climate Change. And politicians jumped on board too. Margaret Thatcher became the first world leader to warn about the dangers of global warming.
The danger of global warming is as yet unseen, but real enough for us to make changes and sacrifices so that we do not live at the expense of future generations. That prospect is a new factor in human affairs. It's comparable in its implications to the discovery of how to split the atom. Indeed, its results could be even more far-reaching. No generation has a freehold on this earth. All we have is a life tenancy with a full repairing lease.
By the early 1990s, it looked like the scientific battle was pretty well over. The idea that a new ice age was on the way had been comprehensively overturned. Scientists and politicians agreed that humans were altering the climate. And something had to be done about it. Global warming had well and truly arrived. And then along came the most familiar of plot twists, the backlash. And what a backlash it was. In the 1990s, global warming was to become the biggest scientific controversy of my lifetime. In a way, Jim Hansen had been too successful. His high-profile testimony galvanised all those who, for whatever reason, disagreed with taking action to prevent climate change.
Simply, this is not whatever. It's just not true.
It was the beginning of an organised fight back, driven by a band of maverick scientists.
Global warming is not a crisis.
Supported by powerful businesses and politicians. And they would subject the whole idea of global warming to a new and searching critique. Next time, the skeptics fight back. How a scientific consensus turned into a vicious battleground, and how science itself was ultimately the winner.